this question is definitely interesting or tricky or confusing, kind of depending on your perspective. A network received telephone calls from a lot of people, and they're trying to determine whether or not the psychic is a fake. So one thing that you'll notice is that they shuffled 5 cards and chose one at random, and then the psychic tries to identify which card was drawn without seeing it. So the psychic either gets it right or not, right or wrong on their guess. That's repeated 50 times, so we have a repetition of this experiment, and we can assume that the results are independent. Then we think that the psychic is fake, like they're just guessing at the cards, just guessing. That means that we have a consistent probability. 5 cards are shuffled, 1 of them is drawn, so 1 in 5, or 0.2, is the probability of them successfully just guessing a correct card. It's repeated 50 times, so we have a sample size of 50. And because the outcome of the experiment is binomial and they're independent, we have a binomial experiment. Once you identify that, then you can start to structure the problem to see what you're trying to do. It's a binomial event. We would like to find the probability that the psychic guesses at least 3 correctly, and we do it in 50 different times. So what's the probability that the binomial random variable x is at least 3, greater than or equal to 3? Well, that's the probability that x is 3, or 4, or 5, or 6, or 7, or 8, or 9, or whatever, up to 49, up to even 50. So that would be a whole lot of values to calculate independently. Instead, let's calculate it using the binomial distribution in the calculator, noting that some of the binomial CDF parts are missing from here, namely all the stuff that happens before 3. So up to and including 2. That's the binomial CDF, the cumulative distribution function, with a sample size of 50, a probability of success of 0.2, and up to and including 2 outcomes, right? Because 0, 1, and 2 are missing, and then we started counting the probabilities at 3 plus 4 plus 5 plus all the way up to 50. Now the probability of the whole thing, green parts included, all the way to 50, 0 to 50, is 1. That's all the possible outcomes of them guessing it correctly. 1, all of it, black, minus the green bit, the CDF, the cumulative distribution function up to and including 2, will give us the probability of guessing at least 3 correctly. So let's pull in the calculator here. 1 minus the binomial CDF (50 trials), p-value of 0.2, and an x-value of 2. That's the one that we are getting rid of, right? We're subtracting it, so we're going to subtract the 2. The probability is 0.9987. So just in guessing, we would expect the psychic to get at least 3 out of 50 cards right. That guessing business helped us talk about this probability. Then we could start to discuss whether or not they do any better than that. If they can do better than that, then maybe they're not guessing.